This micro-credential addresses concrete uses in agriculture and consists of 5 targeted skills. This targeted skill provides information about materials in concrete. There are 4 basic materials in concrete. They are Portland cement, fine aggregate, coarse aggregate, and water. An aggregate can be defined as mineral rock fragments or sometimes even mineral crystals. These materials react together to give concrete its many qualities. When they are combined and placed in a form, they begin a series of chemical reactions that eventually harden them into a single solid mass that becomes fairly permanent. Portland cement is a mixture of limestone and clay that hardens as it cures, even underwater. It is a very fine mixture that is added to the other dry ingredients and then activated chemically by mixing with water. The cement is the binding agent that helps hold the other aggregates and materials in place when it is finished curing. The curing process begins when water mixes with the chemical elements in the cement and causes a heat-releasing exothermic chemical reaction known as hydration. This exothermic reaction gives off heat and produces the strong bonds that help to hold the concrete together. When it is finished curing, the result is that the semi-liquid mixture becomes a solid, rock-like mass that has the desired shape. It is very important to provide the right amount of water when mixing concrete. Too much water weakens the chemical bonds that are formed. Too little water, and there might not be enough for it to mix properly with all of the aggregates. Concrete with low amounts of water is also difficult to place and finish. The largest portion of the concrete mixes is the coarse aggregate. These are generally in the form of small rocks, which can be limestone, sandstone, or pebbles. Crushed concrete from previous projects can also be used in new concrete as long as it is the proper size and not easily fractured. A fine aggregate used in concrete mixtures frequently is sand. The sand should be of various sized particles to allow it to fill in spaces between the larger gravel pieces, which make the concrete stronger. The amount of sand used in a mix compared to the gravel or coarse aggregate varies according to the type of concrete desired and what it will be used for. Regardless of the mixture used, it is important that the aggregates be clean and free of dirt, foreign material, or debris. All of these things can create voids in the final mixture, which weakens the overall concrete structure. Impurities can also prevent aggregates from bonding together, which can cause other problems. Aggregate must be dry to be used in concrete. Sometimes excess water in the sand can affect the curing process and weakens the bonds between all of the materials in the mix. In addition to the basic ingredients, extra materials called admixtures can be added to the concrete to help improve the final results when the concrete is mixed or poured under less than ideal conditions. These admixtures can accelerate or slow down the curing process, make the concrete easier to pour in place, or reduce water in order to improve the strength of the cured product. Before concrete is ordered and mixed, it is important to have the location ready with forms to place and finish the concrete. Understanding that concrete formation is a chemical process, not simply a drying process, is important because it impacts how much time will be available to place and finish the concrete. It is also important in determining when the concrete has reached its full compressive strength. Remember that Portland cement, fine aggregates, coarse aggregates, and water are the 4 basic concrete materials. Knowing the correct proportions of each in preparing concrete is vital to successfully building strong, long-lasting structures.